Remember we talked about a vector space. We're interested in knowing how to identify a subspace. So first of all, suppose you have a vector space. Let V be a vector space. So when we're talking about vectors, we remember some of the examples that we did in class. For example, you have the plane or the space itself, or R to the fourth, or in general, n tuples. You can think about C of A and B, which is the vector space of all continuous functions between A and B. You can talk about, for example, f of x or f of p, or other vector spaces, including the polynomials of degree n. So here you can add n or p as a subscript. You can talk about M of m and n, the vector space of all m by n matrices, and all of those. So when we're talking about vector space, try to remember one of these examples. Suppose you have a vector space, a non-empty subset like W of vector space V is a subspace when it is a vector space with the operations additions and scalar multiplication defined in V, with the same addition and scalar multiplication defined in V. Remember this theorem as well. A non-empty subset W of V is a subspace if and only if for any two elements, vectors, U and V in W and scalar C in field F, the linear combination CU plus V is also in W. So this is a nice shortcut to verify that if you have a subspace or not. Note that for every vector space like V, we have two trivial subspaces. One of them is set including 0 vector and also V itself.